Okay. So yesterday we discussed about alkane and these were the properties. The last point which I was saying, that was flammability. Remember, flammability that decreases with increase in molecular masses. Now, next we are going to discuss another thing about these alkane series. So let's talk about them. Their chemical properties and their physical properties. We have discussed about physical properties yesterday, but now the chemical properties of these alkanes. So the general formula of alkanes is CnH2 and plus 2. So the first chemical property of alkanes, that is combustion. So what is the meaning of this combustion? Actually, combustion means burning process, or you can say the reaction of an alkane, any compound of an alkane with oxygen. In presence of oxygen, let's take one example, CH4, the name of this alkane member, that is methane, right? When it reacts with oxygen, it gives us carbon dioxide and water. Along with this, we get heat. It means this reaction is exothermic reaction. So remember one thing, that whenever any alkane member undergoes combustion, it will give us carbon dioxide and water. And both these products are in gas form. Water vapors will be there. And all these reactions, they are exothermic because heat is produced. So what is then use of this reaction? It means when if we take alkane and we burn them in presence of oxygen, so they will give us heat. So the use of this reaction, that in domestic use for cooking, right? So this methane gas we use in our homes for cooking purposes, and similarly another use, that is they are used as a fuel. I'm not talking about the methane fuel, the other one, like octane, that is one of the member of alkane series, that which is used as a fuel in our cars, which is known as gasoline, right? So butane, that is also used as a gas for cooking purposes. Normally, we use it as a camping gas for cooking purposes. So the main use of this reaction is using these alkanes as a fuel. Is it clear? And remember, this combustion reaction has two different types. For example, if we have oxygen in excess, right? So it will give us carbon dioxide and water. So we call these type of combustion reactions as complete combustion. So complete combustion of these alkanes will always give us carbon dioxide and water. For example, if I use ethane, C2H6, and react it with O2, that will give us carbon dioxide and water. Definitely exothermic reaction. But mostly they will ask to balance this equation. Whenever you want to balance these equations, combustion equations for alkanes, so remember one thing, how can you do that quickly. First of all, balance the carbon atoms. Here we have two carbon atoms, so I will place two here because I need two carbon on the right side as well. So if the carbon atoms are balanced, now after that, balance the hydrogen atoms. Here I have six, here I have two, so I will place three here. The hydrogen atoms are balanced. Now at the end, balance the oxygen atom. So here I have two oxygen atoms on the left side, while on the right side, I have 2 into 2, 4, and 3, 7 oxygen atoms. So how many oxygen atoms I need here? Here I have 2, so I will place 3.5. So multiplying it by 2, I will get 7 oxygen atoms. So that my equation is balanced. But if you want to balance this equation into a whole number, so how can you balance it in a faster manner? So you just multiply this whole equation by 2, right? So it will give us 2C2H6. It will give us 7O2. This will be 4CO2. And this will be 6H2O. So both equations are acceptable either in fractions, 3.5, or in whole numbers because the molar ratio is same. So let's try one more example. Let's say if I have propane, C3 and H8, and its complete combustion giving me carbon dioxide and water. Okay, so first of all, I will balance. Let's balance it quickly. 3, so I will place 3 here. Carbons are balanced. 8, I'll place 4 here. Oxygen atoms are balanced. So 3 to the 6 and 4. 10 on the right side. So very simple. How quickly I balanced this equation. Why I am focusing on this balancing of equation? Because most of them are given in the questions and calculations are given about these type of reactions, right? Okay, so sometimes we have seen that if we burn these alkanes in a limited supply of oxygen, so incomplete combustion, that is known as incomplete combustion. So it means if I have CH4 and I burn it in a limited supply of oxygen, let's say it's a limited. So instead of carbon dioxide, what I will get? I will get carbon monoxide and water. So it means incomplete combustion. Or sometimes it also gives along with this carbon atoms, right? Carbon monoxide and water. So that is known as a limited incomplete combustion when we get carbon particles in the form of a smoke, right? So black smoke actually indicates those carbon atoms which are not oxidized because of the limited supply of oxygen. So two types of reactions you have to remember. Complete combustion will give you carbon dioxide and water, and incomplete combustion will give you carbon monoxide and water. So this carbon monoxide, it's very important. It is actually a poisonous gas. Okay. Why I am calling it poisonous gas? Because when we inhale this carbon monoxide, so it blocks the supply of oxygen to the tissues and cells of our body because it combines with hemoglobin and prevent oxygen to combine with the oxygen with the hemoglobin. So that's why this carbon monoxide actually hinders the supply of oxygen to our body. So, if we inhale carbon monoxide for a longer period, so what are the indications? First of all, it will cause headache, right? And if we keep on inhaling this carbon monoxide, so that will cause unconsciousness, and ultimately it leads to death. Why? It means it is very poisonous gas and it is colorless and odorless gas. We do not uh, detect this gas produced by the combustion. So that's why whenever there is we are performing any combustion reaction in our kitchens, so or in our rooms, like we are using gas heaters, so there should be a continuous supply of oxygen, fresh oxygen or air. So vents should be there. So oxygen can enter into those rooms, because after the use of this oxygen in complete combustion, due to less oxygen, it causes the production of carbon monoxide. So this one is the very first reaction of alkanes and its uses. And now, next reaction of these alkanes I'm going to discuss, that is their substitution reaction. A very important thing which discussed yesterday about alkanes, they are actually saturated compounds. Why? Because every carbon atom is making four single covalent bonds. So they are saturated compounds, no more vacancy available. But if something or any element wants to react with these alkanes, so it has to substitute one of the hydrogen. For example, let's take this example, CH4. As we can see, all the four vacancies of carbon atom, they are occupied by hydrogen atoms. And I want to introduce, let's say, chlorine on it. So, how can I introduce this chlorine atom to the carbon atoms? The only one possibility, first of all, this hydrogen should be removed. So, if this hydrogen from the carbon is removed in the form of HCl, so now vacancy become free, available after the departure of this hydrogen from the carbon. So this chlorine atom now can attack or can make a bond with carbon atom. So you can see what we observed, that one of the hydrogen is substituted by the chlorine atom. So this is the simplest way to remember this substitution reaction. So what is actually substitution reaction? That one of the hydrogen is substituted by another atom. In this case, I am using halogen, chlorine, which is going to substitute one of the hydrogen atom. So it means when we react alkanes with the chlorine in presence of sunlight, clear? In presence of sunlight, they react together and giving us a product, HCl, as a byproduct. And this new compound, the naming of this new compound is also very important. So actually, I can say this product is a derivative of this alkane, which is methane. So it means this compound is derived from the methane. So for its name, I will use the name of this compound from which it is derived. So if it is methane, so what is the difference in this case? One of the hydrogen is replaced by the chlorine atom, so it will be chloromethane. Chloromethane. Is it clear? So it means, okay, now what if I react this chloromethane CH3Cl with another chlorine molecule? Okay. How can I get the product? So you can see what we discussed in the previous example. So HCl will be our byproduct, and this hydrogen is substituted by the another chlorine atom. So this will be our product. So you can see one more hydrogen atom is substituted by the chlorine atom. Now, I want to name this compound. This one, our reactant was chloromethane. Now, in the product, we have two chlorine atoms bonded with the carbon. So it will be dichloromethane. Why? I'm using the prefix di because there are two chlorine atoms. So this process will keep on going until all the hydrogen atoms are substituted by the chlorine atoms. Now let's try to name this product. If I have three chlorine atoms substituting the hydrogen atoms, so the name of this compound will be trichloromethane. Now, if the last hydrogen atom that is also substituted by the chlorine atom, so we will get this product CCl4. Four chlorine atoms, it will be tetrachloromethane. So all the four hydrogen atoms are substituted by the chlorine atoms. And remember the conditions of these substitution reactions. Sunlight is very important because in absence of sunlight, this reaction will not occur. So these are the two basic chemical properties of alkanes. They always show substitution reactions. Why? Because they are saturated compounds and they cannot give another addition reactions because all the vacancies are satisfied. And one of the example of these substitution reactions is reaction with halogens like chlorine, like bromine in presence of sunlight. And this reaction is a chain reaction and it will end when all the hydrogen atoms are substituted by the chlorine atom or halogen atoms. And remember, it gives us a mixture of compounds like chloromethane, if dichloromethane, similarly tetrachloromethane. Okay, what if I give you a reaction to find out the products? For example, if I have this ethane, right, and I want to react it with ICl, and I'm giving you an instruction that iodochlorine or ICl is a molecule which behave just like chlorine molecule. So we can predict the products easily. As I said, that one of the atom of a molecule of halogen that will take the hydrogen and we get Hi, And this position of hydrogen will be occupied by the chlorine. So sometimes they give us these type of reactions to find the products, right? So HiNCl. Now the name of this product. Okay. As I said, the name of this product, it is derived from the reactant, and the reactant name is ethane. If it is ethane, then our product will be chloroethane. Is it clear? So
Yes.
they can give these type of reactions as well. Instead, they are saying use ICl instead of Cl2, and they are reacting similarly. So find the name of the products hydrogen iodide and chloroethane. Substitution reactions. So these are the chemical reactions of these alkanes. Yesterday we discussed about the properties of these alkanes. And now in our next sitting, we will discuss about another homologous series, which is alkene. Is it clear? Any question about it? You can ask any question.